Right, we're going to consolidate what we have learned in this session and the previous session to look at a real life situation. Your boss comes up to you and says, right, we've got all of these transactions and all of these employee numbers. What I want to know is what employees' numbers have not been used for transactions. So not used for transactions. So it's fairly simple to get those which have been used but which haven't been used. We'll see if you can work out a way of doing it using what we know. Okay, so the first thing you might think of is, well, we've got these employees. So what we're going to do is I'm going to take all of those which are in the employees table. I'm going to left join that with the table transaction on the employee number. And I want all of those employees where the team employee number is null, i.e. there is an entry in the table employer, but there isn't one in table transaction. And I just want the employee number from table E. So there we are, job done. And let's order by employee number as well. So your boss looks at that and goes, no, that's not the right answer. Okay, why is that not the right answer then, boss? And he says, well, there are other employee numbers which haven't been used. And you go, what? And you have a look at the base data, and you can see that we start off at employee number 130, but sure enough, employee number 2 hasn't been used. So we need a list of all the employee numbers which haven't been used, and this is regardless of whether they are in the table employee table. So we can't use this join on an employee number for that. So what we need therefore is a list of numbers. So how are we going to generate a list of numbers? Have a think about how you might generate a list which is purely numbers. I mean, can you see a list of purely numbers anywhere? Sure we can. The row number. Okay, so we're going to get the row number from this, and then let's get the row number from this to start with. So select row number, and also select null as row number from table transaction. Order by select null. There we go. So we run this, and we now have numbers from 1 to 2486. Now we're going to join that with the table transaction. So this is a sort of self-join. So left join table transaction as T on, oh, well I want the row number, but the row number isn't one of the options in the original table transaction because I can't use this row number as we discovered a little while ago. So how am I going to get access to this row number in a join? The answer is by using a with. So with numbers as, so now we have encapsulated numbers in a separate table, a temporary, very temporary table, only temporary to the scope. So now we can left join these numbers with the transactions. So we're looking for the row numbers being equal to the employee numbers where the employee number is null. And what we want to get is a list of the row numbers. So these will give us the missing employee numbers. And sure enough, we've got 2, 5, 7, 9, and so forth. 41, 42. And if we scroll all the way down to the end, it goes all the way to 2,486. Your boss says, actually, I don't want it to go all the way to 2,486. I just want it to stop where the row numbers stop. Ooh, look, so why the employees currently being used in table transaction stop? So where did they stop? Well, they stop at, the latest one is 1125. So how can we adapt this select statement to only go as far as 2215? We use the top 1125. So that, as this is a non-correlated subquery, I can run it by itself, only goes up to 1125. And so now if I run the entirety, you can see that there is now no order. So I better put an ordered reference, ordered by row number. And now we've got an order 250 and all the way down to 1120. So we have just solved one of the problems. Now, what if you didn't have table transaction to hand as a means of generating numbers? Well, can I recommend another table which you'll always have called sys.objects? So this contains all of the objects and you can, that are in the database, and you can see it's 115 rows, but we need 1125. But that's fine. What we do is we do a join with another version of objects. And what sort of join would accomplish this? Something that gives us a Cartesian join, a cross join. So now if I run this, we have 13,225 rows, which is the previous number we had squared. So now we can select the row number from that. And there we have a ready-made list of 13,225 rows. So you can use that in here if you so wish. Now the boss says, hang on, this 1125 is a hard-coded figure. How can we get that to be a dynamic figure? In other words, if we add a new employee in table transaction 1126, and I want this figure to be updated. Well, what is the way of saying what is the largest employee number in table transaction? It's the max of the employee number. So, we don't need this order by now. So let's run it again. So we have 1125. So let's put this in as a derived table giving us one answer. Actually, this is giving us a single scalar answer. So can we do that? Well, let's have a look. There we go. So yes, we can do that. So now this 1125 is dynamic. It gives us the same answer, but now if table transaction gets expanded, then so what? It will automatically recalculate this number. We've no longer done a hard figure of 1125. We have now done a soft number. So we've now done a calculated number. It can automatically update itself based on the contents of table transaction. So there you go. This is how you can solve this problem of finding out which numbers are not contained in a particular transaction based on just them not being there, and you have to generate your own table of numbers to correlate that with. So there we have a real life example.